Hello, and welcome to another episode of The Future Current. I'm your host, Sean Swentek. Today, I'm joined by Joseph Mills, Asset Manager, Battery and Solar at Ormat Technologies, Inc. Joseph, thank you so much for joining me today.
Thank you very much for having me, Sean.
Really excited for this conversation as we're just talking about a lot of really critical topics in the industry right now that we're going to cover today. So for my listeners, this is one you're going to be really excited to tune into. Joseph, for many years now, you've managed large-scale PV and battery storage assets to design and development of microgrids for data centers. These are two of the most demanding power environments today, large format solar and battery storage and microgrids for data centers. So what are people missing when it comes to the people who are driving success in these critical applications and the people who are maybe just kind of struggling and it looks a little bit like vaporware?
As far as microgrid, it's really about the integration of current traditional generating assets. So whether it's nuclear, obviously that's a whole different topic, but natural gas, coal, and how then we're going to integrate that with the renewables. And for me, it's not one or the other. It's really a mix right now to actually see which one, not say would win out, but which one is more reliable, which one is more resilient, because it's not necessarily about the megawatts available. It's also about the megawatts available with grid infrastructure.
Yep, that's the critical component, right? Now, you've worked, like you mentioned, across the spectrum of energy, nat gas, solar, battery storage. How do you think your experience in some of those traditional energy markets has informed how you approach deploying renewable energy assets to meet demand at these, whether it's a data center with a huge energy appetite or whether it's a large scale PV or battery storage asset?
Yeah, so trading gas, natural gas and power has given me a more broader approach to it, to that market discipline and risk pricing, which then goes into that real-time dispatchable load when you're working on load curves around storage or solar. And so you start to become a lot more of a trader than a generator, because you're trying to match that load curve with what the shape curve looks like, what the demand looks like, in the ramping hours of, say, the morning ramp or the evening ramp, and how to put the mix of technologies together to be able to have firm base load generation like a traditional gas asset or a coal asset or nuclear asset, or maybe even geothermal because that technology is coming through and gaining prominence as we speak.
Yeah, I'm excited about what I'm seeing with geothermal.
Yes.
You mentioned batteries. Those are really starting to come out as a way to sort of firm up that intermittency of renewables. And until recently, battery storage for large C&I and for utility scale was not really happening. It was seen as more as like a nice to have. What do you think has changed? Why now do many see battery storage as like the foundation of the future of our energy system globally?
Because it's really balancing the mechanisms for that frequency. It starts to take away some of that volatility, and then it gives resilience in that renewable integration. And because you can underpin it, you can then start to add different elements of that traditional generating asset with the storage to give you that dual flexibility that you might need for those large data centers or large loads or data mining companies. So it's really about that mix. And as battery technology grows, we are starting to see how you can really be able to shape that load and therefore help that grid as well. So it's not just a behind the meter. It's not just that energy independence of we're behind the meter, but it's being able to have that mix of being able to rely on the grid and being smart in when you charge and you discharge, and those traditional assets.
I know that you do a lot of work in PJM territory. They've got some pretty complex market rules. How do those regulatory structures affect how you operate and monetize solar and storage assets day to day?
Yeah, there's a lot of market rules, and we are seeing, especially since the redesign from October the 1st of this year, how, if you have a bad 5 minutes, that could change your rolling average quite considerably. So it's very critical that you understand the various mechanics of PJM. So understanding the regulatory market capability clearing price, needing to understand your mileage ratio and your lost opportunity credits are critical in not only navigating the space, but finding out any, let's say, monies that are left on the table to be able to optimize both financially and in a compliance fashion.
How do different independent system operators and RTO market structures affect your operational and financial strategies when you're managing renewable energy assets?
Yeah, I mean, that's very critical because our fleet are across CAISO,
Yep.
across ERCOT, across PJM. What works in PJM, where they want more consistency in
Mhm.
regulation and ancillary services, is going to be very different to what they're trying to do, where they trying to temper down that volatility and those larger price spikes, if you like. So it's very critical to have a overriding portfolio of these are the checkpoints that we like to do in terms of the whole operating fleet. And then within that, can you break it down into subsections? And what you start to see is when you break out some things within a particular ISO, it might translate to a bigger, wider portfolio management.
In the past, Joseph, I know that you've argued that our current grid structure was not designed for the energy system we're building today. What needs to fundamentally change, in your opinion, about market design to unlock battery storage, renewables, whatever, full potential in our system?
It's important to understand that in order for the grid to survive and to move into this transitional period, move through the transitional period, again, I might be biased, but storage needs to underpin it. And we can need to go from that hourly mark
Mhm.
where we don't even know because substations are very specialized. We don't know how they even interact or speak to each other, which we know that they don't.
Yep.
So for the utilities to then go down to a sub hour or a 5 minute period will give it a greater resiliency. Obviously, that fundamentally changes what their business structure looks like, how they operate, how they do maintenance, and then how they do things like virtual power plants if they need to do any grid upgrades or any transmission upgrades. But I think that by them doing that, A, will give them greater forecasting, and B, actually give them that greater flexibility that they think their current structure gives, but actually doesn't because there are these new batteries and new technologies adding onto the grid. And I also think that they need to recognize that a battery storage energy system is not only a generator, but can be a load, and to treat it sort of in a symbiotic relationship and not force a company to choose one or the other.
So then when you're stacking revenue streams for storage assets, especially in PJM, capacity, energy, ancillaries, what is the revenue opportunity that most asset managers might be underweighting right now?
Definitely energy arbitrage in the smaller hours is a big thing that someone may overlook because they might just look at a price spike and where it was before and where it came down afterwards.
Mhm.
Obviously, that five that might be 5 or 10 or 15 minute increment. If there's a price spike for 15 minutes, it might, as it drops down, there's an arb there in a 5 minute play. Obviously, you might need a 24-hour desk. Now
Right.
you're starting to trade more than you're actually sort of managing or
Yep.
providing service. So that's a very important piece. And obviously the lost opportunity credits in providing the regulation on what you missed out on in energy. If you can understand what those lost opportunity credits are around your LMP and around your node, that could be a way to optimize to a stack revenue, but also firm up your modeling.
Now, when it comes to solar plus storage, how does pairing those two together change the operational and financial profile compared to just standalone storage?
It definitely smooths out the shape. That classic duck curve can be managed. where solar curtailment comes in the middle of the day between, let's say, 11 a.m. or maybe 10 a.m. and 3 p.m., that might be a great time to be able to charge up your battery to then smooth out that classic duck curve, if you like. And it makes your revenue stacking a lot more assured because you have the confidence of what your batteries can do, especially if you're co-optimizing the batteries for those curtailment periods in the middle of the day. So you might be able to have that negative or lower energy price. Might be the best opportune time to charge up your battery for the evening ramp hours between, let's say, 5 and 9 p.m. of a particular day.
Like I mentioned earlier, you've seen the microgrid space from both the developer perspective and the asset manager perspective. For, say, a newer investor in the market, what do you think the biggest gap is between what that asset owner and manager is thinking they need and what developers know will actually deliver value for them?
So a lot really focus on independence rather than the resilience
Mm,
that is needed, and they also miss that control layer. The idea of software. It's not about putting more hardware on it, but then how do we then tie that with the software so that maybe the hardware can speak to itself and
mhm.
act as one unit or as a, let's say, a set of robots. One set is taking lunch and another set is not. Like, so that might help with a decent analogy for people to understand. If you can group some of these data centers together, let's
Mhm.
say in one location or one particular state, if you like, it might then become a lot easier to really work them and work that flexibility into it so that they're not all taking, power from the grid all at the same time. And it's really about working with the grid. So it's about working smartly with the grid, not necessarily being off grid.
I like that. When you're evaluating a new microgrid project for a data center or some other large facility, what is the single biggest factor that makes or breaks the economics for that deal?
Oh, the single biggest. Wow.
Or
Okay.
you could share top 3 if you like.
Yeah. I mean, the single biggest would be your coincidental load of when you are ramping up or using the data center to when the grid actually needs it.
Mm,
And that high cost could be a game changer. I mean, that could change economics almost immediately. The other thing would be the interconnection queue. So where are you in the interconnection, and how, not only that, but how flexible can you be with your interconnection? Because having flexible revenue will determine whether you can stay the course of a 18-month, 2-year, 3-year interconnection queue to be able to tie into the grid. So I think those are really the two main drivers of scaling economics on a grid level.
we're hearing some news about potential options to speed up some of those interconnection queues for those data centers. We'll see if that comes to fruition, but that would certainly change the game in a big way.
Yeah, yeah.
What about the topic of flexibility since you mentioned it and intermittency and these things? Do you see that as a viable path to getting more data centers built more quickly? Like, do you see that as viable to be intermittent and to be flexible with these data centers on their power needs?
Yes, I really believe so. And I think as more go towards GPUs versus CPUs in the chip technology, that
Mhm,
will give a greater flexibility. A lot of data centers love to say that they need, 4 nines or 5 nines in terms of reliability.
mhm.
But even getting it down to 1 nine, if it's at 99.9%, and even taking 7 or 8 or 9 hours, maybe every quarter,
Yep.
that that might lessen a huge load, a
Yep.
huge burden off the grid.
Yep.
So it's really important that as they gain greater flexibility and as the chips start speaking to each other, we know that NVIDIA's Spectrum X chips are now being able to in real time, being able to speak to each other, which is the analogy I brought up before. Not everyone takes the lunch break at the same time. So if a data center or a large load is ramping up at a certain time period, it might lessen another time that another data center might be using. And I think that flexibility is critical in moving forward through this transitional state.
I love that. And now it's a really cool way to think about it. And I think you're spot on in how it could actually play out. Yeah, I mean, data centers are some of them, at certain points of the day, at least, they can't afford downtime. They've got demand needs that they have to meet. So, do you have any other thoughts about how do we balance renewable integration as an energy source with those reliability demands of these like critical facilities? Are there any other ways to get there?
Yeah, I think forecasting is going to be very important to
Mm,
be able to understand where are there coincidental and incidental load. And we also need help from the ISOs and RTOs. I think this is the critical point, because if those utilities are not careful or the ISOs are not careful, they will start to lose their grid to, well, lose their grid, I should say, in quote,
yeah.
lose their grid to the hyperscalers. They will now become the utilities because they are demanding such high megawatts
Hmm.
that they are now dictating to the utility what can happen. And if I was speaking from a utility, I would obviously I wouldn't want that. If but then again, I don't want them to completely break my business model.
Yeah.
So I need to be able to go and work with them and understand when they're going to need the power and how much they're going to need, and for us to be able to work together with other companies that are putting renewables on the grid and make it an all hands on deck situation rather than picking winners and losers.
Mm, well said. No, I don't want to assume, but based on your years of experience, I can imagine that there might have been a moment where an asset didn't perform as expected in an important moment in time. How did that inform for you lessons around reliability and forecasting? Speaking of,
Yeah, so that reading reinforces the idea that the best models still need real world
Mm,
experience, and they need real world plugging in and to see what that actually looks like. That variance is is a big thing, and you need to be able to take that step in order to see what it looks like around all of your mitigation strategies. So that also starts with being humble and having some humility around the data,
mhm.
and what percentage of error can you allow for in order to test out the models. So, and that's the key piece, because you can model for a long time, but until you actually put it into practice,
Mhm.
into the real world experience, it's yeah, it's only as good as it is on paper or on the spreadsheet. It's really that implementation and not being afraid to pivot quickly to a new strategy that you've already lined up, because you can't just put it in and say, well, this is the best case scenario. Okay, well, what's your worst case, your medium case, and your best case scenario? And being able to pivot as quickly as you think, not being able to be tied down to one specific idea. And I think that's where my experience in trading has come in, because you have to, if something is going south against what you thought and what has traditionally been, oh, it always does this and it
Yeah.
doesn't, then you've got your mitigation strategy and being able to pivot. So I think that that experience is very important, to be able to pivot and change.
Yeah, I mean, you can do all the digital twin work and modeling and everything you want, but that real world human experience of having been through it before is kind of the second factor in the end, I think.
Exactly. Yes.
You mentioned earlier interconnection queues really at historic highs. Timelines keep stretching for projects. How does that reality reshape project feasibility today for PV storage and hybrid systems, renewable energy systems?
Again, it's about having that flexible capital, making sure that while you're in that waiting period, you are not just having idle megawatts. So can you provide any kind of service that might help in the interconnection queue? We are also seeing some ISOs and RTOs allowing, instead of a larger feasibility report of greater than 15 megawatts, a lot of developers are doing projects under the 15 megawatts or 10 megawatt cap and coming in at 8 megawatts and trying to, or what, something under 10,
Yeah.
and trying to, move ahead because the feasibility reports are a lot less stringent for that kind of modeling. And I think it's also incumbent upon developers to have a dual strategy, both front of the meter and behind the meter strategies, to show to the ISO and RTOs of this is how A, we can provide a service, and B, you can also rely on us in different ways that they can show both to their customers and to the ISO.
Yeah, I assume you've negotiated many a PPA in your life and have managed many infrastructure deals. What has changed most dramatically in how buyers approach energy contracts in the last 5 to 10 years?
We've moved from a very price centric PPA to a very risk centric PPA. So what are we doing around force majeures? What are we doing around leasing and permitting for the sites? And obviously letters of credits. So I think those have become very much more of the forefront, rather than people were very obsessed about price. You model, this is what the capex is and everything else, and then very, very stringent upon price, but then not really taking in too many of the other factors. Obviously, it was in play, but it didn't have as much weight as the price. And now corporate buyers are really looking for that flexibility, and that ESG has changed. It's become more energy independent and energy dominance, so they're really looking for that. So those are the real two things that I have seen recently that has been on the forefront when we have been negotiating.
Now, Ormat works across a lot of different technologies: geothermal, PV, storage. I don't think nuclear, but I could be wrong. How does managing a diverse portfolio compare to being like a specialist asset manager in a single asset class?
It really builds resilience because you've got to try to optimize within all those different subcategories. So obviously what works for solar doesn't work for storage and doesn't work for natural gas. So yeah, it's about co-optimizing those assets, and then it's about trying to collate that data to work across all different platforms. So how does your solar inform your storage? How does your storage evolve your geothermal? So it all comes into play as to a cross integration between asset classes. So that's a very important factor that we take into as we make these decisions.
So 10 years from today, as we look back, what do you think we'll realize we got completely wrong about the roles of energy storage and microgrids in the clean energy transition?
I think speed of the deployment.
Oh, okay.
I think people truly are truly underestimating where this AI technology is going to go. People have some idea, but I don't. Even I'm very open to the fact that I read a lot and I understand the industry, but I still don't. I keep saying we're in a revolution, and some of my colleagues think, yeah, maybe, but I really do believe we are going to be blown away in the next 4 to 5 years. And I also think as the confluence of peak oil demand, which is in 2030, even though we're not going to stop using oil, I think just the idea that the world is going to be like, oh, in this year, this is the most oil that we're going to use. This is it. And we are now on a downward trajectory. I think that's going to really push this revolution, if you like.
Yeah.
And that's my words. And I also think that autonomous vehicles acting as batteries is what's really going to push things, and understanding how AI needs to work together in a smart way, almost like virtually. If you look at things in Europe, what might be happening in Germany could have ramifications of what's happening in Belgium, in Spain, as the grid gets integrated, and you add things like wind and other renewables to it. So I think those are the things in the next sort of 10 years that people have understand, but maybe are underestimating a little bit.
I'm with you on the revolution. I love that visual you gave me of these roving dispatchable power sources, these battery storage EVs that
Yeah.
going where they're needed. I
Yeah.
love that idea.
One more thing, I think if you take it even down granularly,
Yeah.
I think every component of your home may have a battery. So your fridge will be able to speak to the lighting in your home, to the lighting in your garden, to the lighting in your shed, to the car that's to your, maybe you have an EV that's plugged in, all of them speaking together. So if you have a home that could be obviously tied in with other homes to provide one battery, and then within that home could be a subcategory of batteries that you are running yourself. So yeah, I
I
see
was
this.
just reading up on a company this morning who's doing exactly that, and it's real.
Oh wow.
It's exactly what you're describing, and it's coming. So I love that. They just
Yeah. So it's already here then.
it's coming. For all my listeners who might be interested in learning more about you and the work you're doing at Ormat, where's the best place for them to go to learn more about your work?
I would say LinkedIn, just
Yep.
either search Ormat Technologies or my name. And yeah, I'd love to connect and yeah, start a conversation with like-minded folks.
Excellent. And I hope to see you maybe at a battery conference or something in the near term and get to meet in person. But until then, Joseph, thank you so much for joining me on the show. It was such a pleasure to meet you and get to speak with you. To all my listeners, thank you for listening in to The Future Current. I'll see you on the next episode.